Hey everyone, and welcome back. Ready for another deep dive?
Always.
Awesome. So today we're going to be talking about one of the most mind-boggling particles out there, neutrinos.
Tiny little things, aren't they?
Yeah, almost ghosts really,
Yep.
passing right through everything. But don't let their size fool you. These little guys are giving us a whole new look at the universe, and we've got some exciting new findings to discuss.
We do, from some pretty incredible sources. Ice Cube, CERN, Novae. These are the big players in neutrino research right now, and they're churning out discoveries.
Seriously, it feels like every week there's a new breakthrough.
It really does.
Well, let's jump right in. We're talking mapping the Milky Way with neutrinos. We're talking blazars blasting these things out. We're even talking the very fundamentals of matter.
Sounds good to me.
So, ready?
Absolutely. Let's dive in.
First off, we got to talk about the Ice Cube Observatory. It's down in Antarctica, and they've detected high-energy neutrinos coming from, get this, inside our own galaxy.
Yeah, that was huge. I mean, it's the first time we've been able to see, well, not really see, but detect neutrinos from within the Milky Way itself.
Right, like we've always known they were there,
Right.
but actually detecting them, that's next level. Why is this so groundbreaking, though?
Well, think about it. Neutrinos are these ridiculously tiny particles that barely interact with anything. Unlike light, which bumps into dust and gas, neutrinos just cruise right through, carrying information from all over the galaxy.
Like cosmic little messengers.
Exactly. So they're giving us this completely new view of the Milky Way, a view we've never had before. It's like suddenly having X-ray vision for space.
And Ice Cube didn't stop there. They actually went and created a map of the Milky Way using these neutrinos.
Yeah, a neutrino map. I mean, who would have thought? It's incredible, like we're exploring a whole new terrain.
It's mind-blowing. We're talking about seeing the skeleton of our galaxy in a way that was never possible before.
And this is helping us understand some of the biggest mysteries in astrophysics, like where do cosmic rays come from?
Those super high energy particles that bombard Earth, yeah, those are a puzzle.
A big one. And we think neutrinos and cosmic rays are produced in the same kinds of events. So by tracking these neutrinos back to their source.
I can find out where the cosmic rays are coming from, like following a breadcrumb trail back to the bakery.
Exactly. Now, speaking of powerful cosmic events, we got to talk about
Oh
blazars.
yeah, Blazars. Those are galaxies with like super massive black holes at their centers.
Right, and they blast out these incredible jets of energy, and guess what? We found at least one blazar that's a source of neutrinos.
No way. That's crazy. I mean, we already knew blazars were intense, but this just takes it to a whole other level.
It really does. I mean, these jets, they're basically giant particle accelerators pushing matter to nearly the speed of light. And by detecting neutrinos from these jets, we can get an up-close look at the extreme physics happening around black holes.
Talk about a front row seat to the most powerful events in the universe.
Seriously, it's like having a probe right inside one of those jets, giving us a glimpse of what's going on in those incredibly extreme environments. Okay, but now let's switch gears for a second. From outer space to, well, a very controlled lab.
Ah, you're talking about the Large Hadron Collider, the LHC at CERN.
The one and only. And they've just made a big breakthrough, directly observing neutrinos being produced in particle collisions for the first time
Oh,
ever.
hold on. So we're not just catching neutrinos from space anymore. We're actually making them now.
We are. It's a game changer because before this, we've mostly studied neutrinos from space or nuclear reactors.
Pretty chaotic places.
Exactly. But the LHC, that's a controlled environment, so we can create neutrinos in a very specific way and study their interactions with much more precision.
So it's like the difference between trying to understand a storm and studying a single raindrop.
Perfect analogy. The LHC is like a high-powered microscope for neutrinos, giving us a crystal clear picture of their fundamental properties.
Wow, that's awesome. And speaking of studying those properties, there's another experiment we got to talk about. NOVA. They're diving deep into neutrino masses and this thing called CP violation.
Ah, yes, no VA. They're tackling some of the biggest mysteries surrounding neutrinos. Now, you ready for a little neutrino magic?
Hit me with it.
Okay, so neutrinos come in three types, or flavors, and they can actually change from one flavor to another as they travel. We call this neutrino oscillation.
It's like they're shape-shifting. So cool.
Right, and Novi is studying these oscillations to figure out which flavor is the heaviest, which is the lightest, and by how much.
So do neutrino flavors have different weights?
That's what we're trying to figure out. And get this, they're also looking for something called CP violation, which would mean that matter and antimatter neutrinos behave differently.
Hold up, matter and antimatter. So neutrinos could hold clues about the fundamental nature of matter itself.
They could, and that's what makes this research so exciting. It's not just about understanding neutrinos, it's about understanding the very building blocks of the universe.
So we've got neutrino maps of the Milky Way. We've got neutrinos shooting out of blazars. We're making neutrinos in labs. And now we're using them to probe the nature of matter. It's incredible how much we're learning from these tiny particles.
It really is mind-blowing, and we're just scratching the surface. Neutrino research is still a relatively young field, but the discoveries are coming in fast and furious.
It feels like we're on the edge of something huge, like we're about to unlock some major secrets about the universe.
Absolutely. Neutrinos are like keys to a whole new realm of understanding. Who knows what other groundbreaking discoveries await us in the future?
That's the exciting part. It feels like with each new finding, we're getting closer and closer to solving some of the biggest cosmic puzzles.
I completely agree. The future of neutrino research is incredibly bright, and I, for one, can't wait to see what comes next.
Me neither. This has been an amazing deep dive.
It really has.
Big thanks to all of you for joining us. And as always, keep looking up, keep asking questions, and keep exploring the universe. We'll catch you on the next deep dive.
See you then.
Bye.
Bye, everyone.